All right, thank you very much. I have heard by text from Rowland, and he is on his way in traffic, so he will certainly be able to speak in the next session. So rolling on. So I'm here to talk about the randomized badger culling trial. As you saw, I was part of the Krebs committee, which originally recommended that we have a trial, and not just any trial, that it was a randomized trial and that it was controlled. So that means, of course, that we have some areas that don't have any culling, so we have something to make comparisons with. And this is the design as it ended up. It has 30 areas, each of approximately 100 square meters, and those were randomized to one of three treatments: proactive culling, which was annually repeated widespread culling of badgers across the area; reactive culling, which was in response to a confirmed breakdown on a herd and was more limited and one-off; and then no culling. And again, that no culling is really important, so we have something to compare to. And so we divided the areas up into groups of three. Each group of three was uniquely called a triplet. And so we had 10 triplets. And you can see how they're distributed. There was some discussion about going into Wales at the time, but there were issues with that, so they were all in high incidence areas of England. The first so it was designed to magically all start at the same time and take 5 calendar years. That didn't happen because not all areas could start at the same time, because there wasn't the capacity to do all the culling in all the areas that quickly. But it got started, and then there was an early stoppage, a discontinuing of the reactive strategy, and that was because of a detection, and it was in a planned interim analysis. So you don't just, it wasn't just someday I decided to look at the data and, hey, there's something interesting. We had planned interim analyses to look at how the incidence was developing, and we found a significant increase, not a decrease, but a significant increase in TB incidence in cattle. This is confirmed TB incidence. And shown here, plotted by triplet, are the results. And you can see that 9 of the 10 triplets had greater than expected incidence. So this straight line represents the number of breakdowns that we'd expect, and we saw more breakdowns per herd than we expected. And the only one that was below was J, and it turns out J was the one that hadn't yet had any reactive culling. So in a sense, it's included for completeness, because that's what we do with a planned analysis. So it's included in the overall estimate, but it hadn't yet gotten any reactive culling, but was included. So the estimate was a 27% increase in the incidence in cattle TB. And again, this is confirmed herd breakdowns. With the confidence interval, we'll go for the most conservative, which is adjusting for over-dispersion, even though it wasn't significant. And so that spreads it then from a 2.4 decrease to a 65% increase. Now at this point, we were obliged, because we found a significant result, to report this to ministers, which we duly did. And we also advised that we would like 6 more months of data to be more certain of what was going on, to look into it more. But we supported what was eventually the ministerial decision based on legal advice, which was that they could not continue with this arm of the trial, knowing what they'd seen. So the reactive strategy was stopped. And in the analysis that we published, we conclude that the reactive culling of badgers as carried out in the trial is unlikely to contribute to the control of cattle TB, as our results showed that the reactive culling was unlikely to create a viable base for future policy. So in order to understand what was going on, there were sort of, I guess, 3 explanations for what might be happening that were put forward. One was that the trial was a complete disaster and it just produced any old rubbish. And we did find consistent results, so that argues against that. One was that farmers in no culling areas were actually meeting up and in a coordinated way culling quite extensively. So we weren't actually comparing reactive culling to no culling. We were comparing reactive culling to quite a lot of illegal culling. And I'm sure there was some illegal culling, but if it was extensive, then we might be drawing the wrong interpretation. And then there was a third hypothesis, was that the culling as carried out in the trial, so the reactive culling, could be causing a breakdown in the social structure, or changes in the social structures of badgers. And so in order to examine these, we looked at bait marking. So bait marking involves bait such as treacle and peanuts, which badgers like to eat, and indigestible colored beads. The indigestible part's very important, so we can see where these beads are distributed by the badgers. So there's a badger, there's a bait, And there's a bait return. So the bait return has these indigestible colored beads, and the color of them, if you put baits with different colors at different, in different social group territories, you can see where the badgers are going from different social groups. And so if you imagine that these big circles are where the main set is in a badger social group territory, and you put red baited here and blue bait there, then you can map them. These are very well-behaved badgers that have social group territories that are well-defined, and we can look and see what happened and we looked at badgers in unculled areas, proactively culled areas, and reactively culled areas. Importantly, we also looked up to 2 kilometers outside proactively culled areas as well, and that was Rosie's suggestion, because she said, well, proactive culling is so extensive that we might be having impacts not just on the badgers that are in those culled areas, but for even up to 2 social groups beyond that. So there's first maps showing reactively culled areas, a reactively culled area compared to an unculled area. So you see in the unculled area, these stars represent, didn't have enough colors to distinguish these, but the stars represent where the baits were placed. And you can see that you get, with convex polygons, relatively separated social group territories. You see fewer bait returns, so fewer of the circles here in reactive culling, so probably fewer badgers. And you also see a lot of overlap between the different colors. And so that's telling you fewer bait returns indicates fewer badgers, although it's difficult to actually estimate how many on from the number of bait returns. But also, these animals were ranging more widely. So if we look here and compare the blue numbers, this is bait returns per set. You see that reactive culling has fewer bait returns per set than no culling areas. So that argues against the idea that there was such extensive illegal culling that we weren't comparing reactive culling to no culling. We were comparing it to some more extensive thing, and that's why it looked worse by comparison. But also importantly, in red, you see the median bait return distance, so how far baits were from the star, the location of the main set where they were placed. And you see that the badgers in reactive areas, there are fewer of them, but they're ranging more widely. And both of these things are important. So I imagine in my mental model of what happens on the ground is that the impact on cattle is a trade-off between the number of infected badgers that are there. Obviously, fewer would be better given that choice, but also their behavior, so that they're ranging more widely, then the threat that they pose may change. And so here's where we looked inside. So this dotted line represents the border of a proactively culled area. As you go to the right, that's deeper inside a proactively culled area. And as you go to the left, that's going up to 2 kilometers outside a proactively culled area. What you see in terms of badger density as measured by number of bait returns is that there are a lot fewer bait returns inside the proactively culled area, so that's encouraging from the point of view of effectiveness. There are fewer badgers in there, so it is working it in terms of reducing the badger population. But as you go up to 2 kilometers outside, you see a significant trend that the bait returns are increasing. So it's having an impact on the level of badgers at least up to 2 kilometers outside. What you'd ideally like to do is measure it so far that we actually saw it plateau, and we saw where badger culling wasn't having an impact, but we didn't get that far out. But also, you see that there's very high bait return distances inside proactively culled areas, but an increasing trend as you go near to the border. So it's affecting both the ranging and the number of badgers up to 2 kilometers outside. So this is not because badgers are running away from culling, because they're ranging a lot inside the culling area, but that their social constraints are reduced when the culling has reduced the number of the members. So in terms of looking at the impact on cattle farms, because we wanted to look at what's the impact of culling on TB incidence, if we see the effects on badgers up to 2 kilometers outside culled areas, these are proactively culled areas, we wanted to look at what's the impact on cattle in that. Yeah. So, at the scheduled endpoint of the trial, we found that there were benefits of culling in terms of proactive culling. So inside proactively culled areas, you had about roughly 20% reduction relative to unculled areas. So big culls can work at reducing cattle risks. but we also looked up to 2 kilometers outside. So we compared cattle up to 2 kilometers outside proactively culled areas with those up to 2 kilometers outside unculled areas. And when we did that, we found increased incidence up to 2 kilometers outside proactively culled areas. So the headline figure was 29%. So both of those are highly significant. So then there's this trade-off if you're going to do a large, repeated, widespread cull between the detrimental effects outside and the beneficial effects inside. And so it should push you to either not culling at all, or if you're going to cull, culling extensively. Because if you have a not very big cull, you're going to have detrimental effects outside that could even mean that you have an overall negative impact. And in fact, if you look at this, and there's one reason why I'm concerned about the prospect of farm-based culling, is that even if we ignore the reactive results, and some people get very concerned about the reactive results and say, it was stopped too soon, it should have been longer, more should have been understood, and we didn't, we did study it further by looking at the bait marking data. Even if you just look at the proactive results predict for small culls on the scale, geographic scale of the reactive strategy, you would get a negative impact. And that's because the detrimental effect outside covers more cattle than the beneficial effect inside. Now, there might be a way that you could make this better. So for example, if you have this area where the outside area includes C, obviously you're not going to be having a negative impact on cattle there. Or if there was an area that had a lot of dairy farm or just cattle farms in one area and then up to 2 kilometers around that, no cattle farming at all, that would be then an area where you could do culling and not have the negative impact. But cattle farming doesn't work like that in discrete pockets. So this shows over time, the red is the up to 2 kilometers outside trial area. So above this horizontal line is a negative impact, and you see the negative impact was greatest after the first cull, and it gradually diminished. The benefits inside trial areas, this is all proactive, increase over time roughly. But then after culling stops, and this post-culling data, which is all these numbers on the right-hand side, are all more than a year after proactive culling stopped. Because testing is annual in these areas, like it is now in Wales, you have to wait up to a year before you can actually sort of look at what happened post-culling. And so when we look at this 5-year period, we see that the benefits of culling actually were greatest up in that 18-month period after culling had stopped. So that's actually 12 to 30 months after culling had stopped. And then it gradually diminished. Whereas the detrimental effect outside was not evident at all. This is just sort of bouncing around. And so over this whole 5-year time period, it's virtually zero estimate of the impact outside. But on average over this time period, this 5-year time period, you get a 28% reduction. So although you pay a cost in a detrimental effect outside during the trial, during culling, once the culling stops, then we don't see that detrimental effect anymore. So it's a trade-off between these things, both time scale and geographic scale. And then finally, I need to add in some mathematical modeling. One of the things that you can do analyzing the data just from the initial proactive culls is to estimate the overall contribution of badgers. The overall contribution of badgers is, sort of trying to get at what would be the impact if badgers magically disappeared, or if you could wave a magic wand and they could no longer infect cattle at all. This is not talking about culling because that's a different issue. They're not completely removed and it's not immediate. So the estimate is that 52% of TB, so this is confirmed breakdowns in cattle, come from badgers in some overall sense. However, that is made up of two components. One is the direct cattle to badger transmission, and the other part for which they're to make a contribution is then the onward transmission of those infections. If we actually look at estimating the direct badger to cattle transmission, we estimate it's only actually 5%, 5.7%. It has a wide confidence interval, but only up to 25%. So I think these numbers are important because on the one hand, we're saying, no more than 25% of TB in cattle, this is in proactively culled areas so high incidence areas in England in this time, was coming from badgers. On the other hand, our best estimate is about half overall of the TB in cattle was a contribution from badgers, but the confidence interval is wide, and again, it could be up to 100%. So it could be that if I waved this magic wand and there was no contribution from badgers, there would eventually be no more TB in cattle. We could eradicate it even with the tools that we have, imperfect as they are. The other estimate that we can look at is in this 18-month period, which was the first post-trial period we published. If you look at those, the overall impact of proactive culling was a 54% reduction. So very comparable to the estimate here, and with a more narrow confidence interval. So taking the first two together, these suggest that the overall contribution from badgers is at least 38%, but maybe as high as 100. On the other hand, if we could completely stop the onward cattle-to-cattle transmission, we'd have no more than 25% of the TB that we have now. And so then I would just like to make sure to thank everybody involved in directly in designing and analyzing the trial, which is my colleagues that were the independent scientific group on cattle TB, and shown here are our secretariat at the time and 4 of our 5 research assistants. Thank you very much.